Hi, my name is Adam Kaplan, and I'm a senior staff engineer on Agents platform, which is part of Core AI at LinkedIn. Today, I'm going to be talking to you about agent-to-agent communication with MCP. I'm going to cover some of the why, and then we'll have a demo from my co-presenter to talk about the what and the how. So where I'd like to start this is way back to trying to understand what exactly we're trying to accomplish with agent-to-agent communication and with MCP. And what we're trying to do is create the fabric that powers the autonomous agentic world. So to understand that, we should get into why agents need to talk to each other at all. All the fact is that agents today don't have very much agency. They're mostly operating in fixed workflows where they choose actions to take out of a very fixed tool set. It's unrealistic for agents to become experts in all tools. So the solution here is to allow agents to talk to other specialist agents. And by doing this, all agents can become more autonomous and be able to operate without a user holding their hand in a fixed workflow. Where does MCP fit into this though? Oh, let's look at how things evolved. First, a couple of years ago, we had LLMs that replicated human language. And we found that we could take that capability and wrap it in some instructions and guardrails and some model specialization to replicate human behavior, reasoning and acting, similar to what we might do. MCP is now coming in on top of this to adapt agentic apps to human communications paradigms. Let's do a quick comparison so that you can see what I mean. For a human, you might send a direct message or an email to another human. With an agent, it would be a tool invocation. Humans ask follow-up questions. Agents use elicitation on the tool invocation. Humans send progress update messages. Agents send progress update messages with MCP. In the end, some work is done and you receive a reply in the human world, and in the agent world, pretty much the same. You can get your reply directly or including a resource URI if you have more to show. We're going to have a demo of how all of this works after this later on in the talk. But before then, I'm going to take a moment to discuss where we are in the world of agentic applications, where agent-to-agent communication comes into play. We are right now riding an exponential wave where every successive generation of models and model infrastructure effectively doubles the capabilities or perceived capabilities of the previous generation. So today we might be solving problems that tomorrow, a few months later, will move lower down in the stack. Agent-to-agent communication is a fantastic example of this. Just a few months ago, maybe 3 months ago, I solved agent-to-agent communication in my project. And that's kind of what brought me and Victor, my co-presenter, together. And today, fast forward a few months, our solution is essentially baked into the protocol in some way, and we don't need that anymore. So given that this is where we are and how things are evolving, I have some tips for everyone out there before we get to our demo. The first is, especially in this area where we're getting into agents talking to other agents, inter-agent communication, systems coming together, remember to be lightweight and flexible. That's what brought me to MCP, or got me interested in MCP in the first place. It was a kind of under-implemented protocol, not very opinionated. It's exactly what we need for this day and age in generative AI programming. Stay model agnostic and build as little in the app layer as you possibly can to achieve your needs. Remember that everything you write that isn't furthering your immediate goal, the thing that makes your app special, is essentially debt that's going to need to be undone in a few months. And the last is get involved with the MCP community, make proposals via PRs, join committees. Agent-to-agent communication is the result of such proposals and committee discussions, which I was proud to be able to witness and participate in to some extent. And it's through all of you that we push this protocol into the future. And now with that, let's roll Victor's demo.
Hi, everyone. My name is Victor Dibia. I'm a principal software engineer with Microsoft Core AI. And today I'm going to walk you through a demo demonstrating how to implement agent-to-agent communication on the MCP protocol. And so a common question I often get is, can you build multi-agent or agent-to-agent communication systems purely on the MCP protocol? Part of the reasons that drives this misconception or this question in general is that if you had tried MCP about a month ago, you might have walked away with the impression that it was strictly limited to request response patterns. However, the recent updates to the MCP model specification introduces new concepts like elicitation, where during a tool call, a server might sort of make a request back to the client to sort of get user input. And in addition to that, there are new concepts such as resumable streams, where across disconnections, a client might be able to reconnect and sort of resume from where they left off during a tool call. So all in all, these new primitives that have been introduced sort of lead us to the answer of yes. Today, you can combine many of the new features of MCP to sort of enable agent-to-agent communication. And so for the rest of this session, I'll first go over a demo. I'll show you an example server I have built with some of these capabilities sort of implemented. Next, we'll go over 4 high-level requirements that I think differentiates a typical tool call from agentic behavior. And more importantly, we'll sort of tie in which MCP features sort of enable this today. And then finally, I'll sort of touch on some potential next steps, more of homework or to-dos that you can do to sort of scale from a single agent on a single MCP server to, let's say, creating more sophisticated patterns where you sort of compose multiple agents across multiple servers. Okay, let's begin with a demo. And so what I have here is an interface that I have built that can connect to a streamable HTTP MCP server. And so the first thing I'm going to do is connect to this server. Now, the first thing that happens is that we list all of the tools available on the server. And you might notice that I have listed them as things like travel agent, research agent, and log run agent. And so typically these are all tools, but the core idea here is that they are long running and they might have some features that sort of differ from a simple request response pattern. So let's sort of take the travel agent. It takes a single parameter called the destination, and we might run that tool. And the first thing we notice is that we get a stream of updates. And so here it says checking flights, confirming dates. And more interestingly, we have a pop-up here because as a tool sort of, or as the agentic tool sort of got executed, it sends an elicitation request back to my web application that says, please confirm the estimated price. And so I might add in a confirmation here. I might add in some text that says looks good. And then I might click accept, and the rest of the tool sort of continues running. And in this case, we see that the final response comes back trip booked successfully. Similarly, we might try out another agent here, and we might give it a topic to research. We might click run tool. Again, we see a bunch of intermediate progress updates that are streamed to the UI. And what we sort of see here is that this tool has requested a sampling update. And so what that means is that it has made a request to my host application for an LLM completion, and my application has responded and it has used that, and we have a final response. Okay. The last tool I like to walk through that implemented here is a long-running agent. And in this case, it has no arguments, but just has a series of steps. The more important thing is that if we look into the notifications that come back here, we can see things like task has started. And we might also see information around the steps that have been completed. Now, the interesting thing about this specific agent is that at any time, the client might be able to disconnect. And as long as my application can hold on to a session ID and a last event ID, then we can reconnect at any time and sort of get replays of all of the messages that were sort of sent while the client was disconnected. And if the final result is available, we also get that. So what just happened? A few interesting things have happened. The first thing is that within an MCP tool, as the tool executes on our user interface, we get a series of progress updates. Now, this is a bit of a departure from the typical request response pattern, and it provides a more engaging and interesting user experience. The second interesting thing that happened is human confirmation via the elicitation capabilities of MCP. As our travel agent tool sort of made progress on the task, it was able to send a request to the host application where it said, do you want to confirm the current price of the travel options that we have found? The other thing is AI sampling. As our AI research assistant tool made progress, it made a request to the host application to make some LLM requests. And then finally, our entire server is resumable. And so in the event of a disconnection, our client can reconnect to the server and sort of get updates. Okay, so let's get into a bit more of the details of what makes a tool agentic. Overall, I think there are about 4 important things that an agentic tool should support. And we'll go through each of them and sort of dig into how MCP supports them today. The first is streaming and partial results. Next is the ability to resume network interruptions. The third is durability. Can we pull for tool call results potentially across server restarts? And then finally, can we get user input during the execution of a tool? So for streaming and partial results, the core problem is that the traditional request response pattern doesn't work well for long tasks. And so, especially from the perspective of providing an interactive user experience to the user, sort of letting the user know how the task progress is going. Another example where you might need partial results is a situation where you might want some sort of early cancellation or early termination behaviors. And let's say we are exploring some type of code migration task. Quite in the middle, we might see from the early responses that they're irrecoverable errors, and it can be useful to sort of terminate the task as opposed to committing more resources to a long-running task that might be problematic. Today, MCP supports all of that. Partially for streaming updates, we can use the progress notifications. In addition to that, there's some additional proposals that are being made to formalize the ability to sort of integrate partial results either in progress notifications or as independent streams. And the way that will work is that the user sort of makes a call to the host application. The host application calls the tool. And then the tool can sort of emit progress updates as the task makes progress until it's complete. The next concept that an agentic tool must support is the ability to gracefully reconnect or resume after a client disconnection. And so, for example, a task might take about 30 minutes, an hour, or even a couple of days. And in that case, it's quite reasonable for host application or client to sort of disconnect. And the good part is that with the streamable HTTP transport, MCP sort of supports the ability for the host application to hold on to a session ID and the last event ID. And as long as the server sort of implements an event store that sort of that can save events or responses that occur while the client is disconnected, then the client can always reconnect with these 2 pieces of information and then sort of recover or resume from where it's left off. And what that flow looks like is as follows. The user can make a request. The host application can make a tool call. And once the host application makes a tool call, it can hold on to a session ID. And as it receives any response from the user, it can hold on to the last event ID. Now, following this initial set of interactions, in the event of a connection loss, the host application or the client can always reconnect to the server provide the session ID and the last event ID, and all of the messages that were sent during the disconnection period are sort of replayed. The third has to do with durability. In many cases, it can be beneficial for a client to want to sort of read the status or result of a task across server restarts. And one way to implement this is to use the resource links capabilities in MCP. And so one of the recent updates is that a tool call, in addition to returning types such as text or images, it can also return a resource link. And here's what that flow could look like. The user could make a request to the host application. The host application could call the tool. However, instead of returning intermediate updates, the host application, the server tool, instead of returning intermediate updates, may choose to return a resource link and essentially continue to process the task in the background and update that resource. Now, the host application at any time can pull the status of that specific tool call by conducting a read or get resource on the resource notification, or even subscribing to updates on the resource notification. And so sort of combining the ability to return resource links as well as pull for the status or content of a resource, as well as subscribe to resource links, sort of enables this sort of durability capability. Finally, multi-turn. It's sort of reasonable that at different points, a tool might require user input. And so this might be user input, this might be approvals, and all of this is supported through the elicitation and sampling callbacks that MCP already supports. So in this case, the user makes a request, the tool sort of proceeds with execution. It might make a request back to the host application and the user for input, and it might make a request back to the host application for an LLM callback. Okay, so far we have, in the example that we've looked at, we have a host application that has a client. We have servers, a server that exposes agents as tools on a single server. A server supports resumability because it implements an event store that's used to replay missed messages. And it also has some idea of persistent storage that's linked to a resource object. One way that we can extend this to even more complex multi-agent behaviors is to mostly expand the scope of the host application. In this case, we might get the host application to do intelligent things like task decomposition. So a task comes in from a user, and the host application might do things like list the agents that are available across multiple MCP servers that it's aware of. It might take on the responsibility of sort of coordinating calls across multiple servers. It might take on the responsibility of managing the state of the user task, and also doing things like sort of exploring retries and then synthesizing a final result. And so I have come to the end of this presentation. Code and additional direction material for this will be shared as part of the session details. And the MCP protocol moves very fast. I'll encourage you to sort of look at the official MCP website, modelcontextprotocol.io, for the most up-to-date information. Thanks for listening.
Well, we are doing a Q&A. That is right.
There is the Q&A. Sorry. They were like, your mic's on. Don't say anything. I mean, I just did it. Sorry about that.
I blame Caitlin. So
I have no idea what that
does that. That was amazing. We actually, this is the first time that Burke has ever heard agent to agent, so it blew his mind. A lot of great comments, people loving it. We did get a great question, Adam, as well as like, can agent to agent communication be asynchronous, like using Kafka, for example?
Yeah, certainly. It's that's at a lower level than the protocol defines, and in fact, I think it's good practice for them to be asynchronous, since these are not people in the end. Delivery failure may happen, and Kafka and those sort of nearline systems give you great retry semantics.
As you and the team have been sort of exploring and integrating and looking at agent to agent, like what have some of the main, like your main takeaways in your learning that like either have excited you or like, oh, this is like a challenge for us in development? Like what are those two flip sides of the coin, basically?
Yeah, it's a great question. I think I tried to cover some of this in my part of the talk, which was a little bit more philosophical, in that it became quite clear that what we've done is equip the agents with their own private version of the human communication systems, like Teams and email and stuff like that. Those are the way that agent-to-agent communication shook out in the protocol reflects how people work, and this makes sense because the LLMs are basically designed to mimic us, and so they're also mimicking our communication styles. It also makes things a lot easier because you don't have to explain to your agent how to respond in an email. It kind of understands what an email is and that it's a longer form thing or whatever. But yeah, hard, difficult things that I discovered. Uh, there are a lot. I mean, what you're talking about long running tasks, you're talking about these sort of semi unpredictable agentic systems and giving them lots of long running tasks and trying to track them and manage them and keep them all moving and isolated, right? Each one's operating in its own silo, but still you need to learn from one task you're doing and apply that generally to all the other tasks. There's a lot more that I expect in terms of progress and support in the stack for this.
Yeah, it's super interesting. I had this thought, Adam, and again, this is more like philosophical, existential, but you're talking about like agents mimicking human behavior, and that's what they're doing right now with coding. But I had this thought that like code is for human beings. It's so that I can translate my thoughts into machine code, right? But the LLM doesn't necessarily need to do that. That's for humans, not for LLMs. So when it comes to agents, do they need to communicate like human beings, or is there a more efficient way to communicate? And I swear to you, I saw this tweet where somebody had agents communicating over like dial-up modem sounds. Did you see this? You know what I'm talking
Yes,
about?
I've seen this. Yeah, and again, that's like wire format. I would put it in, right. Like MCP operates on HTTP, but perhaps you want to operate in another transport under there, including like dial up tones, if that makes sense. But that's just how the messages are getting between the agents. There's still the like, do we need code, or is there a better way for agents to get things done? I think I don't know the answer to that yet, and it's very philosophical and sort of meta. I don't think we're quite there yet, and we're still trying to fit them into our systems because our whole world is designed around our systems. And for them to be most effective, they need to conform to our shape for now.
That does make sense. And it does also make sense to me that like if I am gonna order a pizza with an agent from my local pizza place,
Yep.
then I want to interact with that agent. That agent's gonna have to use the existing systems that that pizza place has set up, which is like a website or whatever. But the good thing is, like all of this stuff exists, so these agents can go out and use this. But yeah. Anyway, I'm looking forward to your book, Adam, on how agents are going to communicate in the future. It's
And we did
good.
get a great comment. Let me boost it here. Boom. Wonderful presentation. Is your team hiring?
We are certainly at LinkedIn. I know. So yeah, go to linkedin.com and
Perfect. John also dropped some links, some great blog posts on building agent to agents and communications, how they work. If you're over there on YouTube, we'll put all the links and the decks and everything we can on the on-demand recordings right here on the Microsoft Developer YouTube. Thank you so much for the amazing presentation, and we have some more goodies coming our way. So thanks again, and we'll put all that into the links on the video.